Hi, my name is Ruth-Ann Armstrong and I use she/her pronouns. Today, I'll be presenting JamPatoisNLI, a natural language inference dataset in Jamaican Patois. I worked on this paper in collaboration with John Hewitt and Professor Christopher Manning. Jamaican Patois is an English-based Creole spoken in the Caribbean by over 3 million people. Creole languages emerge as a result of contact between groups of people with no common vernacular. Jamaican Patois in particular developed as a result of contact between enslaved African people and British colonists in the 17th century. Though there are millions of Creole speakers globally in different regions across the world, Creole languages are vastly underexplored in NLP research and belong to the class of low-resource languages. Further, Creoles are a uniquely interesting point of study within NLP as they often share high overlap with high-resource languages like English. This gives researchers the opportunity to study cross-lingual transfer between languages with distinct spelling, tense, and structure, and high vocabulary overlap. Our paper contributes to addressing the gap in research on this class of languages. To our knowledge, JamPatoisNLI is the first natural language inference dataset in a Creole language. It consists of 750 examples across training, validation, and testing. In our paper, we conduct zero-shot and few-shot experiments exploring cross-lingual transfer from English MNLI to JamPatoisNLI. We also present a comparison of cross-lingual transfer efficacy for JamPatoisNLI to cross-lingual transfer efficacy for America's NLI. Finally, we run qualitative experiments which leverage the relatedness between Jamaican Patois and English to better understand cross-lingual transfer. Let's begin with discussing features of Jamaican Patois. The sentence presented here is written in Jamaican Patois. We see that the language has distinct spelling, tense, and structure from English. However, there is a high degree of vocabulary overlap. Strictly non-English vocabulary highlighted in bold accounts for less than 1/3 of the words in the sentence. Our Jamaican Patois dataset gives researchers the opportunity to study cross-lingual transfer between languages with distinct morphosyntactic features and high lexical overlap. A second feature of the language is that it exists on a continuum. As we stated earlier, Jamaican Patois developed from contact between enslaved Africans and British colonizers. Because it is a hybrid of the languages spoken by two groups of people that came in contact, it exists on a continuum that ranges from more dissimilar to less dissimilar to English. The terms for the classes on the continuum are the acrolect, or variations which are closest to English, the basilect, which denotes variations which are furthest from English, and the mesolect, or variations which are in between. The table above shows different translations of the English sentence, "I'm eating the food that they gave me." The basilectal extreme of the continuum consists of words that are nearly exclusively non-English. Nyam is used rather than eat, and bickle is used rather than food. On the acrolectal extreme of the spectrum, or Jamaican Standard English, the example is identical to English. In our qualitative experiments, we leverage this feature to better understand cross-lingual transfer between English and Jamaican Patois. Constructing the natural language inference dataset was a multi-step process. First, we gathered premises that were pre-existing. 97% of examples were drawn from Twitter, and the remaining examples were drawn from a cultural website, Jamaicans.com, and from literature by Jamaican poets Dr. Louise Bennett Coverley and Shelley Sykes Coley. Next, for each premise, a corresponding hypothesis was written by a native speaker so that the pair's classification would be entailment, neutral, or contradiction. Then, a random sample of 100 sentence pairs, evenly distributed across the 3 NLI classes, was double annotated by fluent speakers of Jamaican Patois. Here we have a random sample selected from the 100 double annotated examples in the corpus, with their goal labels and validation labels abbreviated E, N, or C by each of the annotators. This table shows some dataset statistics. The dataset size is limited because Jamaican Patois is a low-resource language, so there is a limited number of naturally occurring examples and a limited availability of native speakers to annotate a large number of examples. In spite of this, the sizes of the training, validation, and testing sets are sufficient for exploring few-shot fine-tuning techniques and obtaining useful signals about the effectiveness of different methods. Now let's move on to our experiments and results. We explored both monolingual and multilingual pre-trained models, cased and uncased BERT and Roberta, as well as cased and uncased multilingual BERT and XLM Roberta. Jamaican Patois is not in the pre-training corpora for these models, but is related to English. First, we fine-tuned the pre-trained models with an NLI classification head on the English MLI training dataset. We experimented with frozen models where the weights of the pre-trained models were not updated during fine-tuning, and with unfrozen models where they were updated during fine-tuning. For the second stage of fine-tuning, where we conducted zero-shot and few-shot experiments, we fine-tuned on the JamPatoisNLI training set and evaluated on the dev and test sets. We also make comparisons to a subset of the languages in the Americas NLI dataset to compare cross-lingual transfer efficacy. Americas NLI consists of examples from 10 indigenous languages of the Americas. Unlike Jamaican Patois, the languages in the Americas NLI corpus are not closely related to any high-resource language for which there are large pre-trained language models or large natural language inference training datasets. This is a summary table containing the results of our experiments for the zero-shot case and for different numbers of few-shot triples. So here a triple means a set of 3 examples which covers the 3 NLI classes: neutral, entailment, and contradiction. So 83 triples covers our full training set of 250 examples. On the full few-shot dataset, Roberta-based models outperformed the BERT-based models, with the Roberta unfrozen model achieving an accuracy of 76.5 and the BERT uncased unfrozen model achieving an accuracy of 66.17%. Interestingly, though Jamaican Patois developed as a result of contact between speakers of English and speakers of West African languages, some of which are present in multilingual BERTs and XLM Roberta's training datasets, the multilingual models were not more effective base pre-trained models than the monolingual models. For instance, the multilingual XLM unfrozen model achieved an accuracy of 75.17% compared to 76.5% achieved by the monolingual Roberta unfrozen model. Next, we compare cross-lingual transfer efficacy on Jamaican Patois NLI to that of Americas NLI. So here we have accuracy on the y-axis and the number of examples on the x-axis that were used for few-shot fine-tuning. And we present graphs for both BERT-based and Roberta-based models. The JamPatois NLI plot is in red, and the plots for the Americas NLI languages are the others. The relatedness of Jamaican Patois to English boosts the effectiveness of cross-lingual transfer in spite of the fact that the languages are different morphosyntactically. This results in far higher accuracies for Jamaican Patois NLI than those achieved on the Americas NLI languages. One question that we might ask for future research is whether vocabulary overlap is the primary factor that led to the boosting effectiveness of transfer learning in these experiments, or whether a higher order notion of similarity is a larger factor. Finally, we conducted qualitative experiments in the following way. We gathered 6 NLI pairs with incorrect predictions in the 83-shot setting. We then created a translation path by writing English translations and valid intermediate Jamaican Patois translations in between. Next, we trained 3 models using the original training dataset and observed which step on the translation path for this augmented test set led the models to switch to a correct prediction. The models began to predict correctly before complete translation to English for 5 of the 6 pairs. In this particular example, the translation of the verb is what led to the correct prediction. We hope that JamPatoisNLI facilitates further research into cross-lingual transfer for Jamaican Patois and other Creole languages. Thanks so much for listening.